Okay, so I'm going to see if I can get through this real quick. Solving nonlinear systems by either graphing or algebraically. So we're going to do this one algebraically. So remember, when we're doing it algebraically, the preferred method is substitution. Not to say that you could not do it a different way, but that is kind of the preferred. So since they are both equal to y, they are equal to each other. I gave you kind of an easy one here. And remember, we set it equal to 0 and try to factor. So when I move things over, I'm getting x squared plus x plus 1 equals 1. And then when I'm minus 1, x squared plus x equals 0. So this one doesn't have a c term, so I'm just going to take out an x. And my two problems would be that x equals 0 and x plus 1 equals 0. So x is a negative 1. Now don't forget, you're not done. Once you get to that point, you do need to go in and then find your y value. So in this case, I'm going to put it into my line. So y is 1. So my point would be 0, 1. And again, I'm going to put it into my second equation, so y is 0. So in this case, my point would be a negative 1, 0. And so that would be my answer. Okay? Now let's look at it graphically. So I am going to graph those two equations. So my first equation is y equals x squared plus 2x plus 1. And so I am going to do the negative b over 2a. I told you I would show you one of those. So the opposite of b over 2 times a gives me a negative 1. And then I'm going to find y. I put the negative 1 in and simplify. And so that's 1 minus 2 plus 1, so that is 0. So in this case, my vertex is at a negative 1, 0. I could also factor it now to find my x-intercepts. So what are factors of 1 that equal 2? Well, in this case, it would be x plus 1 and x plus 1, which means that my x would be a negative 1, 0. And that's not, negative 1, and then I put it in and I get the 0. So that's really not going to help me at all, because I already know my graph hits at a negative 1, 0. Okay? So I'm going to do my y-intercept, which is at 1, which makes my reflection. And then I could put in 1. Let's put in a 1. So that's going to give me 4. So I am at 1, 4. So what I do, that was 1, 2, 3, 4, roughly up here. And again, my reflection point. So here is my graph. Okay, very poor graph. Let's see if I can straighten that up just a hair. Yeah, a little bit. Okay, and now I'm going to do my line. And my line was y equals x plus 1. Okay, which means that I am going to have an intercept of 1. I have a slope of 1, so I can either rise and run, that's going to come over here, or I can go down and left, and hopefully you see that it's actually going to hit at those 2 points. Now, technically, this green graph does come down. Should have kind of curved a little bit so you can see just a little bit of it underneath. And so my answer, again, is going to be 0, 1 and a negative 1, 0. Which again corresponded to what I had up above. Okay? Now, remember, you could have a parabola and a line, parabola and a parabola, or it's possible, which I may give you some in class, you could have an absolute value and a line, or an absolute value and a parabola. Okay? And then we're going to stop there with graphing, and then we'll talk about different types of applications.